execution time that can be improved. S is the speed up factor of the improvements. Let's solve each scenario step by step.
Okay. So there are some things we must understand. If let's say I have a computer system, right? So for example, in the question here, someone else should read this for us. Okay, since no one is volunteering, then it means I must apply for.
Okay, sir, I'm reading.
Okay.
Okay, all right. Assuming your computer's processing spend 90% of its time running in the CPU and 10% waiting for service from the disk. Suppose also that someone is trying to sell you a processor area good that is 50% faster than what you have. And then it costs Ghana city 500 cedis. The day before, someone had called you on the phone offering you a set of disk drives for Ghana city 350. This new disk promises 2.5 times the throughput of your existing disk. And then you know that your system performance is starting to degrade. So you are bent on doing something. Which will you prefer to yield the best performance improvements for the least amount of money?
Okay. Now, when you have a computer system, let's see, hypothetically, right? Hypothetically, I hope you can hear me.
Yes, sir.
Let's say hypothetically, your computer system is running at 100%. Ideally, that is what you want. You want a computer system that runs at 100%. But in the real world, that's not going to happen. You're going to realize that your computer system is going to run not at 100%. This is because some of its performance will be wasted or will be allocated to something else. So in this question, for example, they are saying that you're assuming that your computer processes spend 90% of its time running in the CPU. That means that if I want to improve the CPU, I am improving the CPU on the 90%. That means 10% of the CPU I do not improve because it is either allocated somewhere or it is with someone else. 10% of waiting, 10% waiting for services from the disk. That means that for the disk, I can improve its 10%. That is what I can improve. So the formula here asks a particular question. The formula in which was read earlier, it is asking us a particular question. The question is, the part I can improve, by how much can I improve it if I buy something new and add it to it? If I was to buy something new and add it to the portion in which I can improve, by how much improvement will I get? Does that make sense?
Yes, sir.
Now, P is the proportion of execution time that can be improved. And and S is the speed up factor of the improvement. So if I tell you that, oh, if you buy, again, according to the question, they are saying that if you go and then buy a processor array upgrade that is 50% faster than what you have, it will cost 500 Ghana cedis. So it means that when I go and buy this upgrade, I will have a 0.5% increment in my performance. They're also telling me that if I buy 2 new disks, they promise 2.5 times the throughput of your existing disk. So this 2.5 times throughput, this 50% faster than what you have, is the S value that they are talking about over here, the S, the speed up factor. By how much will I get improvement? They're telling me that I can improve a particular portion of my device. If I improve that portion of my device, by how much will my computer improve? Back to the question here again. Now, from this question, I can deduce the following. I can deduce that 90% of the time running in the CPU, which is my P for the CPU, is 0.90. I can deduce that waiting time for the disk service, which is also P, but for the disk service, is going to be equal to 10%. I can deduce that for me to upgrade the CPU by 0.5%, that's a 50%, my S is equal to 1.50. Now, the question then comes in here. Sir, where did you get 1.50? Because even if you change 50% into decimal percent, the decimal rate, I would get 0.5. So where from the 1.50? How did I get 1.50?
Okay.
Now,
Hello, sir.
yes.
Oh, okay, please. Are you asking us to answer or you?
Do you know the answer?
I'm taking. Let's assume the overall performance is already 1. So 50% adding to it, making it 150. So let's say 150 by 100.
Very, very good. The device itself is saying is already 1. They said that over here in the question. They said that suppose also that someone is trying to sell you a processor array upgrade that is 50% faster than what you have. That piece of English there, what you have. So what I have now is 1. And you are adding what? 50. Hence, I'll have 1.50. So already I have 100. You add 50 to it, divided by 100, like he proudly said, will give me the 1.50 as a decimal rate. And they are saying that this will cost me 500. They're also saying that for the disk, note that the first one is for the CPU. For the disk, I am going to have 2.5 times faster. So S is equal to 2.5. The English there did not tell me I'm adding to anything. It told me that whatever I have is going to be 2.5 faster. So I write there 2.5. There's a reason why I ask someone to read the question, because if you do not understand the question, you cannot solve it. You must understand the formula. You don't chew the formula. You realize a lot of you from wording, from the day students, from wording, from the evening students, some people who call me say the formulas are too much. Why are you chewing the formula? If you understood it, you do not need to chew it because you must apply it. Now, if that is true, then I can put that piece of information into the formula where 1 over 1 minus p plus p over s. So I know my p, I know my s, so I'll put the values in the location, and that should give me speed up of my CPU. That should tell me what is the speed up. The speed up is if I make a change based on the proposed or the said rate that the change would give me. This is the performance value of speed I am getting. So if I make a change to the CPU, this is what I'm getting. I'm getting 1.4286 proportionally. If I go and do the same thing to the disk, then I am getting 1.0638 proportionally. But you see, these two proportions here are meaningless to me until I compare them with the money. The money. So they're saying that the money I would use to spend to increase my performance over the rate of speed up I got, which is 1.4286, will give me 350. That is cost per unit. That means that if I make this upgrade and I spend 500, I'll be making 350. If I make this upgrade and I spend 350, I'll be making 329. Now, if I'm putting 500 Ghana into something and I'm getting 350 back, it makes sense. Now, for the same thing, if I put 350 Ghana cedis into it and I'm getting 329 back, look at the difference between 350 and 329. And look at the difference between 500 and 350. To you, which one is better? Which one is value for money? Which one? Obviously, the one for the disk upgrade. So it means that when I solve for the speed up, I would have the cost of the thing divided by the speed up. That would give me the cost per unit performance. And it is based on the cost of unit performance that I would judge and decide, do I go with me upgrading the processor or do I go with me upgrading the disk? And that is why I keep telling you people that in the exam, if you solve up to here and you don't conclude by saying that based on these two values here, I will go with the disk. Or based on everything in which I have done here, I will go with the CPU. If you don't use the information here to deduce and make an inference, then what have you learned? The whole point of this question is to inform someone with data. Don't just come and show up and say, Charlie, we top processor never work. The processor never man computer is fast. The processor, Charlie, the processor is our brother. There is no point in talking and the bravado. The facts will show you which one is better. The math shows you. So if you, after solving the math, can't make an inference, how do you get that question correct? Why do you get that question correct? Because you've solved everything, but you can't deduce that if I'm spending 500 and per Each improvement I get, I'll get 350 back. And if I spend 350, I'll get 298 back. That means that this one I'm saving money to give me a lot of improvement. The loss here is not as big as the loss in which I'm getting over here. Hence, I will go for this one. If you can make that deduction, then we have a problem. That's why I said you solving this has marks, but the conclusion has more marks. And if you can't show the maths that backs your conclusion, then everything is wrong. Because anybody can just go and copy from someone and say that this, do the disk. Why should I do the disk? And you are standing there. And a lot of time in our offices, in our workplaces, we know we want upgrades on our system. But how can we justify the upgrade to our superiors? And this is how we can justify the upgrade. Are there any questions? Does anyone have a question? If there are no questions, let's go to the next question. One of you should read what is on the screen. One of you should read what is on the screen. Please, there's no time. This thing in which we'll have to say one of you should read, we have to wait for you to decide. Charlie, one of you should just read the thing. If I see that it's just one person previously, I'll start to mention names.
Okay.
Your enterprise database server currently spends 80% of its time handling database queries and 20% waiting for data from storage drives. A consultant has proposed a server processor upgrade.
The reader, give me a second, I'm coming in. But you can read for your classmates.
Grade for 400 Ghana cedis. That triples the data retrieval speed from storage. Which upgrade would
Yeah, continue.
Another vendor has offered an SSD upgrade for 400 Ghana cedis. That triples the data retrieval speed from storage. Which upgrade would provide the most significant improvement in overall system performance for the least cost?
So I want to know the p-values. I want to know the p-values for the two things we must compare here. I want to know the S values and the P values for them. I also want to know, yes, so I want to know for you, what do you identify as P? What is the point for P? What is the point for the second P? I also want to know the S for the two values. I'll give you 1 minute and then I'll call someone to tell me what they think it is. Okay, Jennifer, what is your P? What is your S for the server?
80%.
80%. Okay. And then the storage drives is what?
I wasn't sure of the yes.
You weren't sure of the S. Okay. And then the
But
Mhm. And then what of the P for the storage device?
20%.
Normally, remember that we are going to be using them as a decimal value. So you have to state
So
0.8
it's
and then 0.20. Exactly.
okay.
Anybody here who got the value for, okay, let's see. Thomas, what did you get for S for the server, the database server?
Okay, there I got 0.6. 0.6.
You got 0.6. The S you got 0.6. I didn't hear that.
0.60.
0.16.
60.
0.60. Okay. And then the S for the data storage, what did you get? Thomas, are you there?
Yeah, yeah. Hello.
Yeah.
The application I got 0.60.
I know. So this is for I'm assuming this is for the database server. So for the storage devices, what did you get for that? Makadai, what did you get for S for the database server? Yeah. There are two values. There's the speed up factor and then the proportion of execution time to be improved. The proportion of execution time should be stated as a decimal value. Jennifer proudly told us that for the database server, the proportional value will be 0.80 for the database server. And then for the storage devices, it is going to be 0.20. Fine. Now, in the second half of the question, they said that gives us the S value, the speed up factor of improvement. So, Mr. Mark, what did you get for the speed up factor? What did you get for the speed up factor?
Speed up factor. 0.
0.6. 0.6. And then the speed up factor for the storage devices, what did you get? Okay, thank you very much. You guys do know that I sent you this slide on Tuesday. Is it Tuesday or Wednesday? One of those days. You should have read ahead. Anyway, over here it says a consultant has proposed a server processor upgrade that boasts query handling speed up by 60% for 700. Another vendor has offered an SSD upgrade for 400 that triples the data retrieval speed from storage. Which upgrade would you go for? So again, in correlating our data, we said over here that a consultant has proposed a server processor upgrade that boosts query handling by 60%. That means that whatever you have, you will add 60%. So obviously, the speed up for the processor is going to be 1.60, because if it is just 60%, it means I have nothing and I increase by 60. But it says it is a top up. So what I have, 60 will be added. So I already have 1. So 0.60 will be added. That is how I get the 1.60. Over here, they said that I am going to remove the SSD drives and I'm going to slot in the new SSD drives that the person is giving me. That means I have nothing to top up. And what I am slotting in, they are telling me that it's going to give me triple the data retrieval from storage. Hence, it means that here, my S4, the SSD upgrade and the drives is going to be 3.0. Ladies and gentlemen, if you cannot deduce the value of P, if you cannot deduce the value of S, the exam is going to be very long for you and you are not going to be happy. And that is why I am going through problem solving with you, because I already always assumed that you guys could deduce things from problems. Until I spoke to someone on Friday and I realized my students don't really know how to analyze problems and pick data from them. So here, my P for the server handling database queries is 0.8. My P for the data storage devices is going to be 0.20. My server speed up is going to be 1.60. It is going to be 60% faster. So whatever I have, I'll add 60 to it. That is what gives me this. And remember, it's not a percentage value. It's a proportional value. Hence, we'll be using the decimal. And then over here, the speed of it is going to be 3 times faster. That is 3.0. And that is what I'm going to get. Hence, if I put these information into the formula that I have, that is 1 over 1 minus P plus P over S. I should get this, which would give me this, which can give me that, should give me this proportion in which I have here. Now, for me to see the monetary value I am getting, it is 700 over 1.4286, which will give me 490 proportionally. Over here, I'll do the same thing for the SSD drives, which will give me 347. Technically, it means that me upgrading the SSD drives will give me a better performance on cost per unit than me upgrading the processor. Hence, I would go for upgrading the SSD drive. There's one more question. For this question, I expect
Hello,
that,
sir.
yes,
Please, can I have a look at the original formula, please?
sure. Is that okay?
Yeah, thank you, sir. Sir, it's okay, thank you.
Okay, So there is another question here. And this question here, all of you should be able to solve it because this is what you did as your midterm. And right now, if I ask you and you get it wrong, that shows me you, the midterm, went to copy and brought it, number one. And number two, from Wednesday to now, you didn't even open the PowerPoint on a teacher will grad or send it then. Oh, like that vibe, which tells me that my students are waiting for the week before the exam of my paper to go and start learning. Don't do that. You will fail. Anyway, let's come back to what we are doing. One nice person should read the thing that is on the board for us. Whilst he reads, everybody should listen and be fetching the information from it. A lovely person should read it for us.
Consider a cloud service where virtual machines spend 95% of their time computing and 15% of their time syncing data with a
David,
Hello?
please, can I go by?
Oh, sorry. Consider a cloud service where virtual machines spend 85% of their time computing and 15% of their time syncing data with distributed file system. A hardware vendor offers 600 Ghana cedis upgrade that improves compute efficiency by 50%. In contrast, another vendor proposes a network enhancement for 350 Ghana cedis that boosts data sync speed by 200%. Using Amdahl's law, determine which upgrade offers the most significant performance gain per unit of cost.
Okay, again, I'll give you a minute. Use a minute, identify the data you get from it. What is going to be your P for value 1, P for value 2, S for value 1, S for value 2. The costs there, they are written there. So I will ask you what are their costs. But for the P's, you must be able to identify. You must grow that part of us. It is okay for us to learn things, but we must be analytical. We must be able to see values and pick them from where they are. Pick them. All right. Rudolph, what did you get for P for value 1 and P for value 2?
The P for value 1 is 0.85.
Okay. And value
P
2?
for 0.15.
Okay. Note that it is not always going to be clear like that.
Yes.
All right. Rudolph, do you know what the values for S for value 1 is?
Yes, I did that.
Okay. What is that done?
For value 1 is 1.5, and the second one is 3.
The second one is 3.
Yes.
Okay. So let's see if Rudolph is right. And wonderfully he is right. The first one we have 0.85. Second one we have 1.15. Over here we have an upgrade that will be 50% faster. Hence, we will be S is equal to 1.50. And that gives us the cost is 600. And over here, they said the network enhancement will be 2000% faster. That means that I already have 100. I will add my 2000 to it, making 300 is the percent, the decimal of it, the two zeros will go away. So I'll be left with 3.0. Note the difference between this one and this one. So that this one here, we said 3 times faster, but we wrote 3 here. We didn't write 4 here because we are replacing the drives. So if the drives are being replaced, it means that we are starting from 0 instead of starting from 1. Over here, they told us that what we have, it will be 200% faster. So if it is going to be 200% faster, it means we already have something and we are improving it. Hence, our S is going to be 3.0, which will be 300 divided by 100. So those kind of changes, you must be aware of them. You must be looking at the problem and solving it. It is very important for this course, very important for your programming course, it's very important for the analytics course. You must be fetching data and understanding it at this level. Of course, once you can do this, then you can put the values into the formula that was given. And if you do that, you will be getting your CPU upgrade to be 1.3953 for its speed up. And you'll be getting your cost per unit performance to be 430. For your network enhancement, you'll be getting 1.111. And then your cost per performance will be 315. Looking at the prices they were suggested and the performance you get per unit, we can see that the network enhancement would be the way to go. And you can see the conclusion by saying that the network enhancement is the way to go. Are there any questions on these 3 questions?
No, sir.
Yes, sir. I think I have a question.
Okay.
So assuming I use a different approach, not the Amdahl's law, and then I've gotten the same, the correct answer.
Before you finish.
Can I still go?
Before you finish. I can
Okay.
see here in the question. Let's read this part of the question. Here, starting from here.
Oh, okay.
Okay.
It's
okay. Don't do okay. You read it. What starting from here? You read it. It says what?
Okay, using Amdahl's law, determine which upgrade offers the most significant performance.
Okay.
Per unit of cost.
Okay.
Thank you.
You in the exam, you have seen the question says using Amdahl's law. Then you say, oh, Charlie, I will use the Amdahl's law. I will use Savannah law. If you give me the same answer, the teacher will take it like that. What do you think will happen? So read it. If the question does not tell you which performance matrix to use, then you are free to use whatever you want. But the moment the question tells you what to use, do not deviate. Are there any other questions? Yes.
So in an ideal environment, you maybe you can afford. So you decide to do the 2 changes. You decided to do the the server increment and you also decided to do the hard drive, you are improving both sides. You're not looking at the money. And then are you saying that now that the machine is going to run, say, more closer to 100% than it was when you changed one? I don't know if you get the question correct.
Yeah, that means that the computer is going to run faster.
Yes, but in relating to what? Is it's a previous performance or
In relative
the
to the previous performance. So,
Alright.
for example, if we take, if money was not a factor to you, that means that my computer is going to run 1.4 times faster here, and the performance will improve here by 1.1583. Now, this is where you must decide if that improvement is significant for you to justify that cost. But you premised your earlier statement by saying cost is not an issue for you. That means that this is the way to go. So in your business, you can justify this and say, okay, we want everything to be great. We want everything to move faster. So this is the way we are going with it. That's fine. That's up to you. That is why the conclusion part here is very important for me. Because over here, it is the only part of the question which is left to you. Because you have to decide. So if your argument is that, no, I want the networking app, justify it. No, I want in this case, the server. I want the server upgrade. Even though it is expensive, I want the server upgrade because the SSD, you have to install it and things is too long. So me, I want the server upgrade. I've left it to you. But over there, you must be knowledgeable enough to know what I have, what I'm going to do, and so on and so forth, and put it in a way that can justify it. Because in our workplaces, we will have to justify the things we do. If you are a systems engineer, if you are the person managing the systems, if you are a systems analyst, for example, you must justify the things you do. You're not just telling we need to buy new computers, or the computers we have are old. If the front desk person is going to be doing a visitor, I came, she's going to open Excel, Mr. Mark came at 2 p.m., left at 5 p.m., and press enter. If that is what she's going to do, and you're telling me that the computer she's using needs an upgrade because she needs, a 200,000 computer because to look nice at the front desk, things like that. Doesn't make sense to me. But to another person, the aesthetics of the company makes sense. So they can justify that by saying the front desk should look nice if she has a mark and everybody sees that she has a mark and you see that our company, there's money there, and people can come. Okay, that's fine. Anyway.
Okay, sir.
Now, in our semester, in the beginnings of our semester, we did questions of this nature, where we were asked to consider the following data of two machines, machine A, machine B, and we're asked to find the CPI and the MIPS of the computer. So we have two computers, and we are judging the two computers on the cycles per instruction. So how much instructions they can solve. Over here, we saw that if I want to judge two computers, it makes sense that I give those two computers the same jobs to do. The same jobs to do. For example, if you have seen me before, you know that I am very tall. I'm not very tall. I'm tall and I'm very large, So if it is a job in which I will have to stand on the table and pick something up, or we are seeing who can touch the ceiling first, I'll probably win. If somebody is, let's say, 5'4", or 5, and we ask him to do that same thing with me, he's cheating because he'll probably lose. If the competition is us going into a hole and getting into a hole, if it's a small hole, I'm not going to enter there because I'm big. Now, for us to judge who is better, it means it must be equal. It means it must be something in which both of us should be able to do, which is fair. So over here, you can see that in this table we have here, I've provided instructions. I've provided the ALU, load and store, branching, and others. And we are saying that percentage-wise of occurrences for machine A, we have stated the percentages there. For machine B, we have stated the percentages there. And we have also stated the cycles per instruction. So it means that the number of times the computer does activities in the ALU is 65%. And when it is doing things in the ALU, it only does one cycle per instruction. Meaning, if there were 1 trillion things it was doing, 65% of that trillion was dedicated to the ALU. So in here, the computer first wants us to find the CPA of machine A, the CPI of machine A, the CPI of machine B. The question then is, what is the formula for CPI? Who can tell me? My students.
Sir, please, a question again.
Yeah, so I can say.
Where just question again, what is the formula for CPI? And also question again,
Sir, I didn't hear you, that's why.
Oh, okay. I'm sorry. I didn't know you didn't hear me. So what is the formula for CPI? Plus, my students, we are 2 weeks away from it.
Okay, so the formula is CPI times the instruction times the I over the instruction count.
So there is something missing from the CPI times the I. It is the sum of CPI times I. If you don't bring the sum of there, you are not doing justice to the formula. So it is the sum of CPI times I over the instruction count, where CPI is the number of instruction counts per instruction type, and the I is the number of occurrences of that instruction type. Now, in this formula here, there are some key things we need to note. The sum of there is just telling us that we are going to add CPI times I. Over here, where do we see CPI? We see CPI over here. And where do we see I? I is over here. Oh, sorry, here is the I, and here is the CPI. Or am I having it wrong? No, I'm having it wrong. Here is the CPI, and here is the I, the number of occurrences. Good. So again, we are looking at the scenario whereby I'm doing this times this, this times that, this times that, this times that. And the formula at the top here says that when I do this times this, I have to add it to the next this times that. That means that it's going to be 35 times 1, 30 times 2, 15 times 3, 20 times 5. So you can see that in the solution of this, in which we have over here, we have 35 times 1 plus 30 times 2 plus 15 times 3 plus 20 times what? 5. And we are dividing these by 35 plus 30 plus 15 plus 20, which should give us 100. Note, the box there is set there a percentage. That is why whatever you do, it will give you 100. There are some questions I may give you that I wouldn't add the percentage. That means that you would have to add 35 plus 30 plus 15 plus 20, and whatever you get is what you divide it by. I want to make that point very clear, because there are some students who, they don't know that the 100 here is coming from 35 plus 30 plus 15 plus 20. All they know is that when you do the top, they do over 10 over 100. Over 100, why am I over 100? There's a reason why it's over 100. There's a reason why. So if the percentage sign doesn't come, obviously, whatever you get down there will not be 100. Take note of that. Now,
Okay, sir.
when I do this computation, I'll get 2.40. And when I do that same computation for machine B, I'll get 2.76. Which of these things does the things faster? It is machine A. Hence, machine A is better than machine B because machine A will do its things at a rate of 2.40, whilst machine B will do its things at a rate of 2.76. Now, you see, this here is saying which one is doing something faster. But if I want to know which one can do, listen to this very well, which one can do as many things as it can do within, if I give it 1 million things, which of them can do as many of them as it possibly can within a particular time frame? So if I give it 1 million jobs, which one can do the most 1 million jobs within that short time frame? That is why we are asking you in the second part of the question that we have over here that you should calculate, you should calculate the million instructions per rating over here. So compute the million instructions per second rating for both machine A and machine B. Show work. So for million, we already know the formula for that. The formula for that is the clock rate in megahertz over CPI times 100 times 10 raised to the power 6. That gives you the million instructions. So the million is 100 raised to the power 6. So whatever you got for your CPI, in our case, in machine 1, what we got for our CPI was 2.40. That means that 2.40 will replace the CPI here, times 10 raised to the power 6. On the top, they are saying the clock rate. If you are very observant, you realize that in the question they said, assume the clock rate of the CPU for both machines is 200 megahertz. So back to the solution in which we are looking at. We are looking at this from the point of view that the top is 200 megahertz. The word megahertz means 10 raised to the power 6. So the 10 raised to the power 6 at the top will come and remove the 10 raised to the power 6 at the bottom. That is why here you can see they have only written 200 over 2.40 because the times 10 raised to the power 6 at the top cancels out the times 10 raised to the power 6 at the bottom. So it means that if I give it 1 million instructions, machine A will do 83.33 of them. Machine B will do 72.46 of them. Which one can do as many instructions as it can? It is the first one. That means that for both, machine A is what? Better. Are there any questions?
Sir. Sir.
I'm listening.
Wait, to me, I don't think there can be an instance where from the speed, which we know that the machine A is faster, when we come to the million instructions per second, it's definitely or obviously going to be the machine A. Or can there be an instance where it will change at the bottom?
Mathematically, there cannot be an instance like that. So
okay.
Normally, if machine A is faster, then in a million instructions per second, it's going to have the larger one.
Okay, sir.
Yes. Okay, if there are no more questions.
So what of where you gave the instruction, the formula for the MIPS to be instruction over execution time times 10 raised to the power 6?
I don't understand your question.
So when we were solving, we used the clock rate over CPI times 10 raised to the power 6. But
Yeah.
you also gave another formula where the formula was instruction count over execution time times 10 raised to the power 6. So when do you use that one?
Use that one when the values you are given are distance. In this case, you have
Oh,
found the CPI. So why would you use the CPI?
okay.
Do you understand?
Yes, sir.
Formulas are given so that in scenarios you would use them. So in the scenario that you have those data found, then you use that one. In this scenario, they are telling us that it's a CPI times 10 raised to the power 6. Do we know the CPI of machine A? Yes, we know the CPI of machine A. Do we know the clock rate? Yes, we know the clock rate. Why would we use another formula?
I understand.
There's another question here. Different clock rate, but basically the same solutions. There is another question here. Different clock rate, but basically the same solutions for you to go and try. Over here, we have binary algebra. Now, I know that you are doing some courses now that are doing this thing here. I know. So, to be honest with you, I spoke about them in class, but I really didn't go into solving the binary expressions one by one because I assumed that my students already have the knowledge from the previous class. That was a wrong assumption. That was a wrong assumption by me. Because again, interacting with some students, I realized they don't know what is going on. Then we can see for all the weekend class, the day classes, what I'll do is I'll put the question there, I'll tell them to solve. And then we'll check if you have it wrong, then we'll see where you have it wrong and go. But today, me, I'm going through each one and explaining each one by one because I can't assume anymore. This thing here, when it comes to binary expressions, there are laws you must know. There is no going around it. There is no cheaping it. There is no I am evening or I'm weekend, so learning is too big, all of those things. There is no going around it. You must know all the laws so that you can apply them. So if you are given the expression at the top to simplify, and you'll be given expressions to simplify in your exam, you must know which law to apply to get what you want. And I said something very important in that the whole objective of this simplifying of expressions is to move the expression to 1 when you are dealing with multiplication and to move it to 0 when you are dealing with addition. So that when you are dealing with addition, anything plus 0 is the thing itself, and multiplication, anything times 1 is the thing itself. So you can see that here they apply the distributive law. That is why whenever I give questions of this nature, I also give the laws. So that you can go and refer to the law and see how it is being used. So over here, all I can do is tell you that over here they use the distributive law. So you do AB, then you come and take A here, AB, then you come and take BC here, A point B, then you come and take A here, A B, then you come and take BC here, BC here. Then you come and take C, then C times A to plus CA. Then you come and take plus CA here. Then C, BC, then you come and take C into bracket times BC here. Now, this thing in which we have over here is a law. If I had an expression on how to break the expression down, that is how I would do it. There is no other way, there's no other miracle teaching formula or whatever I can come and do. It's a law and it's being applied. The same way over here, I will group the things in which are alike. And after grouping the things which are alike, we can see here that the law states that A times A is equal to A itself, and B times B is equal to B itself. That means that wherever you have A times A, it is equal to A. Wherever you have A complement times A, it is equal to 1, and A complement plus 1, A complement times A is equal to 0. A complement plus A is equal to 1. Those kind of things are things in which are in the laws, and I gave you all the laws. One thing in which I realized when I started doing computer science, and I realized this when I was doing my master's, is that everything is connected together. Everything. When I started doing my I learned machine learning, so to specifically word embedding and semantic reasoning and so on and so forth. And the math which was being applied there, you can see that in one question they are using sets, they are using matrices, they are using graphs to show closeness and similarity and all of those things. And you realize that this is the math being used. So you are forced to not only learn the math, but apply it. And the moment you apply, you realize, oh, this is so easy. Yeah, it makes sense. And I was telling one class in which I was teaching that the degree, they haven't written there that this person is a weekend student, so consider him for their job. And the job you are doing now, that most of you, especially the evening and weekend students, most of your mentality is that I just want a certificate so that I can get upgrade from work. Why are you worrying me like that? You realize that after the school, the same work you are doing now is the same work you'll be doing when you finish getting the degree. So what was the point of the degree? Isn't the point of the degree to upgrade yourself? Anybody can get A. What is A? A, classwork, you do classwork, get 30, exam, you try and get 45. You have gotten A. What is A? You do some, you go and look for the teacher's past questions, at least 30% of the questions will come from there, read around small, you get a 45. Knowing the thing, spending the time to know the thing, is a different ball game altogether. A lot of you are unhappy with your work, and you would want to move to a different department, you want to move to a different skill set. But we spend too much time not learning stuff. We do. Mid-term questions in which I gave you, you can solve. Questions I gave you on Wednesday, you are seeing them now because you haven't even gone through them. What if your entire exam is what I've given you? If today was the exam day, you would have gotten 0. Can you imagine that? Something in which you have been given, you should have looked at, you're getting 0. There's no going around this. And luckily for you, I know you would suffer with the loss. So you can see that for every question I've given you of this nature, I give you the laws. So that you can go and refer to them and see, oh, this is what this law is talking about. This is what they are doing over here. And you can see that in the solution of this for the breakdown, you can see that they moved everything to 0. Why? Because they were doing addition. And anything plus 0 is meaningless. You have done no change. You guys are workers. So I will never come to a class and tell workers this is what you have to do and this is not what you have to do, because life is already there for you. But I've taught too many weekend schools and evening schools to realize that some of the students, they are just there because they want upgrade. Or they are just there because they said, if you don't come to school, they will increase your pay or something. But who says that in life you have to finish school and work where you are? Who says you can't apply for a better job? Who says you can't even stop and work for yourself? Who says that the work in which you are in now, if the work is giving a financial output of 1 million Ghana cedis, because of what you've learned in school, you can't go and make it 2 million Ghana cedis? Who says so? Shouldn't be okay with where we are. Anyway, with most of the examples, as I said, I've given you the laws and what the laws are. I do not know how to teach it, especially on an online class like this, how I'm going to write it one by one and whatever. But the laws are there for you to go and watch them and apply. So please do. Another thing in which I wanted us to talk about today was the cache hit ratio. So calculate the effective memory access for this computer system. And I realized that a lot of you do not know what the cache is. I don't know why. I don't know how. But there is a reason for the cache. Sorry. There is a reason for the cache. And let me see if I can use today to explain it. And then we can do a walkthrough of the question. So here, look at this picture very well. Hope you can see my screen, right?
Yes, sir.
Yes, sir.
We have central processing unit, we have cache, we have memory. Back in the day, there was no cache. There was only memory. That means that if I was transferring information from my CPU, I just sent it directly to my memory and then I came back. The problem of this whole setup was that it was slow because let's say the computer decides it needs something in memory. It will have to go to memory, look for the thing, find the thing, then send it back to the CPU. So someone sat down and said, okay, let's put in a cache in the middle here. When you are looking for something, first come to the cache. When you come to the cache and the thing you are looking for is not there, go to main memory. And when you are coming back, leave a copy of the thing in cache and go to the central processing unit. Why is this? Now let's look at things from the perspective of our daily life. And what we do with our day-to-day. If you were cooking, say you are like me who cannot cook. So let's lose a simple thing we can all do. Let's say creating tea with egg and bread. If you break the egg and you put it in a bowl, you would have to pick the saucepan. And where you pick the saucepan and put it on the fire, the matches will be close to the fire. So you can pick it from there. The salt will be close to where the matches is and where the spices is and then it will also be close to where the onions are. So that everything is close to each other. So when you go and you pick them and you put everything together, you don't have to be walking around the whole room. You don't say that, okay, I will put my onions in 3 rooms away from the kitchen. So I have to go there and go and fix it. Everything is close to where it is. So logically, if I am going to memory to pick an item and I put it here, and I go back here to the CPU, the likelihood of me going to take an item, that same item again, is very high. So instead of me now going back to the memory, I'll just go to the CPU, the cache, and pick it up. There is also another thing that says that if I go and I pick something up from here, there is a high likelihood I'll pick something that is close to it or something that is near it. So when I'm coming back, I'll pick all the things that are near what I have already gone to pick. So that when I bring it here and I'm coming back, if I don't find the thing I picked, I'll find something near it here and pick it too. So that I don't have to make the whole journey of going back to the main memory. So the cache made it so that transfers are very fast between the CPU and the cache. Now, over here in our slide, I can calculate the effective memory access time. That is, if I am looking for something and the thing in which I am looking for is not in the cache, or it is in the cache, how long will it take me to get the thing? So if I move from here to cache, I can't find it, I go to memory, I come back to the cache, and I come back here. What is the time that it takes me to do all of that? Now, they are also saying that for me to calculate that, I need the cache, the hit rate, the cache access time, the miss rate, and the miss penalty. Okay. So back here, if I go here and I find what I am looking for, then I have a cache hit. If I don't find it, then I have a cache miss. If I find it, first of all, I have to look for it. So the time I spend looking for it for me to have a hit, I must calculate it. Because when I get here, I must look for it, find it. And that word find it, imagine this. Imagine you have no knowledge of knowing if you have found something or not. That means that technically you must see the thing, oh, black way, is it this or is not that? Is it the correct shape? Is it the correct data type? Oh, yeah, it is this. So the time it takes you to do all of that thing there, is it that or is not that? All of those things there go into me discovering the thing and saying, oh, it is that. It is, I found it. So not only am I looking for the thing, I must also decide if I have found it. Then return back to the CPU and tell it that, okay, I have found it, here you go. So they are saying that this formula here gives you the effective memory access time. So if you know the hit ratio, if you know the hit, which is 1 minus the miss ratio, if you know the cache access time, and if you know the miss penalty time, which is the access time plus the memory access time, that is, if I go to the cache. Don't find what I am looking for. I have a miss. Now I have to go to the memory, look for the thing, return back to the cache. Tell the cache that I have found the thing and come back to the CPU. That time after I have identified I have found the miss is my penalty. So they're saying that the penalty is the cache access time because I had to look through the cache to know that I couldn't find it. The time I went to the memory to find the thing. If I add those two things together, then I have my miss penalty. Now, all of these things in this formula would give you my EMAT, which is 8. So I have explained what goes on here. And with that, I have explained this entire slide. The first half of the slide I skipped because most of the things there, I am assuming, and again, I shouldn't assume, but I'm assuming that you people can go through it. That is the diagrams here and then this diagram here, what would be the value of A and all of those things. Do I have to go through them with you or you are okay?
So we are okay.
Go through the slide. As I said, next week we have a class. The next week after that is your revision week. I will not come during your revision week. And then the next week after that, you guys are starting exam. Prepare for the exam now. Don't wait for 1 week for exam. Then you say, major leave, spare 2 weeks because you are the other whole thing. Start preparing now. And that whole thing whereby we are workers half time is a myth. Yes.
If we have a question, can we post it in the group?
Well, of course.
Okay, sir. Thank you, sir.
That whole thing, you could do anytime, and drop. You know what time. You could do my, you so could do it now. If you are 30 minutes, be now they are cabo home same room. Italy, Messi, you know for us, Ronaldo, you know for us. That 30 minutes, use it to learn. When they give you that 1 hour lunch, that 30 minutes you use to walk to the reception and talk to the nice reception lady, Charlie, how are you today? You are looking fine today. That conversation, use it to learn. Anyway, thank you so much for coming today. I know there's no question, so I won't even ask you if there's a question. We'll meet again next week.
Okay, sir.
Bye-bye. I'll send the video for the class in you.
Okay, sir.
All right, sir.